All right, we're going to start our new unit out talking about graphing exponential functions. So the parent function for these is f of x equals b to the x. Okay, a few facts about this parent function over here. So b, if it's a number bigger than 1, it's called exponential growth. Okay, and then if b is a number in between 0 and 1, so like 1/2 or 1/3, that's called exponential decay. Take a look at both types of examples today. The domain for these is all real numbers. So that's for every type of exponential function. It'll always be all real numbers. And then the range is going to be y is greater than 0. Okay, and this might change depending on if you shift it up or down, something like that. Okay, and then one more thing about these is these graphs always contain the point 0, 1. Okay, unless the graph gets shifted left or right, up or down, changing this point, that point will always be on there, because if you raise b to the 0 power, doesn't matter what number b is, because any number raised to the 0 power equals 1. So 0 is the x, plugging that in for x over here, and it's going to always equal 1. So that's why that point always shows up on all these type of graphs. Alright, so let's take a look at y equals 3x. This is be an example of a parent function with the b value being 3. Okay, the parent, there's one parent, like linear functions all have f of x equals x for all types. Exponentials, it changes depending on what that number is. So it could be 3 to the x, or 2 to the x, or 1/2 to the x, just depending. Those are all considered parent functions because they're all only to the x power, not like x plus 5 or something else like that. Alright, so let's make a table of values over here. So we go -2, -1, 0, 1, and 2. Alright, and then we're plugging in this. So this is going to be 3 to the -2. And 3 to the -1, and 3 to the 0, so on. Okay, we actually want to know what these things equal so we can put them on this graph over here. Alright, let's start out with the easy ones. So the positive one's 3 squared, that's 9. 3 to the first power, that's 3. 3 to the 0, we just talked about over there, is 1. Okay, 3 to the -1. Remember, you take the negative and you move it to the denominator. So this is going to be 1 over 3. There's 1 over 3 to the positive 1. And so this will be 1 over 3 to the positive 2. But 3 squared is 9, so this is 1/9. Alright, plot these on our graph over here. So you've got 1/9, and then we've got 1/3, and then we've got 0, 1. Then you've got 1, 1, 2, 3. And then 2, 4, 5, 6, 7, 8, 9. Alright, draw a nice smooth continuous curve through those. And you'll see that these exponentials get really big really fast. Alright, if we went up to 3 cubed, x equals 3, that'd be 27. So it gets really big really fast in these exponentials. Alright, another thing you'll notice that if I kept going negative, and if you take a look at this in your calculator, you can really see that, it never goes to 0. It'll be 1 over 27, and then 1 over 81, and then 1 over 243, and so on. Okay, so it gets really, really close to 0, but never actually gets to 0. And we've seen this before with rational. They have what's called an asymptote. And this asymptote is right here on the x-axis. So it's got an asymptote at y equals 0. Okay, now that asymptote will change. Notice the correspondence with that and the range over here, the same numbers. Okay, that will change based on if we shift this up or down, left or right, stuff like that. Well, not really left or right for this one, but up and down for sure. Alright, let's take a look at a decay function. So all the same hallmarks of the growth one, just the b value is going to be a fraction instead of a whole number. Alright, so let's use these same values over here. Alright, so again, this is now 1/3 to the -2, and 1/3 to the -1, and 1/3 to the 0, and so on. Now remember, when you do fractions with exponents, you apply that exponent to both the top and the bottom. So this one down here is 1 squared and 3 squared. Well, 1 squared is 1, and 3 squared is 9, so that's 1/9. Alright, 1 to the 1 is 1, 3 to the 1 is 3, so 1/3. anything raised to 0, okay, again, this always contains that point, is equal to 1. So that whole thing is equal to 1. Okay, now this one, when you have a negative, the easiest way to think of it is this whole fraction flips over. So 1 over 3 becomes 3 over 1. And then that changes it to a positive one. So this is really 3 to the positive 1, which is 3. And this is 3 to the positive 2. 3 squared is 9. So it's kind of the exact opposite of the last one that we just looked at. Okay, so we've got negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And we've got negative 1, 3, 0, 1, 1/3, 1/9. Alright, so you'll see how this one, we draw a continuous curve through these points. Starts high, finishes low. Hence the name decay versus the last one, which started low, ended high, exponential growth. This also has that asymptote at 0, because no matter how big we make our exponents, third power 1 over 27, fourth power 1 over 81, and so on. So it still has that asymptote at y equals 0. Alright, so now we're going to take a look at some transformations. I'm not going to go through exactly what everything means, because it's the same exact thing as we've done the last 7 times. We just recently did this again when we talked about parent functions, alright, last week. So if you need to refresh your memory, go back and watch that parent function video at the end of it. It talks all about these different transformations we're going to do here. Okay, so I'm going to start out with, this is going to be my parent function, y equals 5 to the x. Okay, I got the 5 from here, and then I'm stripping away all this extra stuff that's transforming it and just getting to the basic function, 5 to the x. Alright, so use our same values here. So this is going to be 1 over 25, and 1 over 5, and 1, and 5, and 25. Alright, now this is where you need to know what all these things do. So like there's a negative in front. That negative in front is going to reflect over the x-axis. Okay, so we'll deal with that. The 1/2, that's a vertical compression by a factor of a half. And then this -2, this -2 is inside. I think of this exponent kind of like the parentheses. It's inside the parentheses, which makes it horizontal. So this is going to shift right 2 units. All right, if they wanted to shift this up or down, they would have put the -2 like down here, in line with the other bigger numbers, not in the exponent. All right, so the reflection and the vertical compression, I kind of do those at the same time. This number is going to multiply the y value. So basically I'm just going to multiply all of my y values here by -1/2. Alright, so that'll make this one -1 over 50. Alright, just multiplying straight across, 1 times 1 and 25 times 2. So this is -1/10. This is -1/2. This will be -5 over 2. Or 2.5 if you prefer, and this will be -25 over 2. 12.5, I mean, if you like. And then shift right 2 units, so that's basically going to add 2. So if we started at 0, shifting right would go to +2. So basically I need to add 2 to all the x's. So that'll make this 0 and 1, 2, 3, 4. Just adding 2 to all these x values. Alright, so this is our function we need to plot here. Some 0, -1 over 50. So, I mean, really, really close to 0. Just right under there, like that. 1 and -1/10, so not that much further down. So, like there. And 2 and -1/2, so it's about halfway down there. And 3 and -5/2, that's 2.5. So, 2.5, like there. And then 4 and -12.5. I'm probably not going to be able to fit here. 1, 2, 3, 4, 5, 6, 7. Yeah, so it's going to be off our graph here, but down here somewhere. All right, so it's basically going to kind of go like this. We'll draw this continuous curve through here, and then we'll just go down like that. So it looks like we didn't shift up or down, so our asymptote's still here at y equals 0. All right, and you'll notice that if you graph like the parent function on your calculator, you'd be able to see how it's a reflection. The compression's a little bit harder to tell just by looking at the graph. All right, but we know that 1/2 in front, that's what causes that. And then you can definitely see the shift right too, because you see some more points over here, especially that 0, 1 compared to the 2, 1/2 one. If you're asked to find domain and range on this, the domain is going to remain unchanged. It's still negative infinity to positive infinity, all real numbers. All right, arrow and arrow. And the range is, well, I guess it is changed a little bit. It's usually 0 to positive infinity, but we've flipped it over now. So it actually goes from negative infinity up to 0. And 0 is not included. This graph never actually touches 0. It gets just really, really, really close. So don't put a square bracket, put a parentheses around 0 because it doesn't actually touch it. All right, let's try one more like this with an exponential decay function. Okay, so it's going to be y equals 1/4 to the x. That's our parent, stripping away all this other stuff. Let's do our same values here that we've been doing. All right, so that's going to be 16 and 4 and 1 and 1/4 and 1/16. Okay, and let's write down what all this stuff's going to do. So there's a 2 in front. That's going to be a vertical stretch by a factor of 2. The +2 that's up in the exponent, that's going to shift it left 2 units. And then see this -3, how it's down more in line with this stuff, that's going to shift it down 3 units. Okay, so the vertical stretch, this is going to multiply the y value. So we need to multiply all of our y values by 2. Okay, I'm going to do a little side table over here because before I make my final table that I'm going to graph. So multiplying all those by 2, we've got 32, we've got 8, 2, 1/2, 1/4 times 2 is 1/2. 2 over 4, reducing it. So this would be 2 over 16, which would reduce to 1/8. Alright, so I have the same x values here. Alright, left 2 is going to subtract 2 from all of the x's. So imagine being at -2, left 2 would put it at -4. So -4, -3, -2, -1, and 0. And then down 3 is going to subtract 3 from all of the y values. Okay, so imagine being at 2, down 3, 1, 2, 3, we're now at -1. Okay, so subtract 3, that's going to be 29, 5, -1, negative 2.5, or 5, -5/2. And then negative 25/8, or sorry, 23/8. Just making 3 a negative 24/8. So 1 minus 24 would be negative 23/8. All right, so let's graph this out here. We've got let's start with these negative ones. We got 0 and negative 23/8. All right, which is just above -3, so like right there. And then we've got a -1 and -5/2, so that's negative 2.5. So right there about. -2, -1 here. -3, 5. 1, 2, 3, 4, 5 right there. And then I won't be able to graph that last one because it's way up here, 29. Alright, so we can see our exponential decay if we draw our smooth curve going through these points, going like this, like this. Alright, and then it's going to kind of flatten out right here at the end. And now our asymptote has moved. It's normally at 0, but this down 3 has caused it to move to -3. So there's our asymptote, y equals -3. If you're doing domain, it's still negative infinity to positive infinity. That's never going to change. Range is changed, however. It's normally 0 to infinity. Now it is -3 to infinity. And again, no square bracket because we're not actually touching -3. It just gets really close to it.